this question is asking, find the flux of F through the closed cone W of height 5 and symmetric about the Z-axis, or the radius of top disk is 2, as shown in the picture. And orientation is it's outward everywhere. This is a closed surface, so as soon as I see a closed surface, the first thing that I think about is it's the divergence theorem. So instead of finding a flux of F dot ds, right, over W, boundary of W, not W, but the boundary, I'm going to find a triple integral over W of d of F dv. This is the either section 15.3 integral, or because I'm going to use cylindrical, think about section 15.4 immediately. So let's first find divergence of F. That D comes with dot, and so it's going to be partial with respect to x of 0 plus partial respect to y of 3y squared plus partial respect to z of 3z, and we end up with 6y plus 3. So that's the divergence. And then from there, what I wanted to do is basically set up the integral. To set up the integral, I sort of immediately see that this is a nice rotation about. So maybe I find a cross section R and Z, and I go with cylindrical. So if I go with cylindrical, I have to, divergence is my integrand in this case, right? So I have to convert my integrand. And converting the integrand into cylindrical gives me 6r sine theta plus 3. Now let's set up. Let me just write this. My plan is to have that integrand times the Jacobian. Then I think I'm going to go with Z. Even though either way is okay, then dr d theta. Over here, I can see r is maximum 2. If you go around that circle on top, so r goes from 0 to 2, theta goes from 0 to 2 pi. Z starts from, let's draw this. If I do a cross section, I get this shape, right? And I have to find what line is this. Top line is obviously z equal to 5, as you can see. Let's find this point to find this line and find the slope and everything. I can see that basically any point on this circle up there is of radius 2 and height 5. So radius 2 and height 5. That's the point. And easy finding the slope. Slope is 5 over 2 because this is 0, 0. So z equal to 5 half of r is the equation, and the bottom. And remember, I'm doing in the z direction first. And so it's going to be from 5 half of r to 5. And then you integrate. Nice things about this is that I know that sine theta is going to disappear because I know that theta runs from 0 to 2 pi, and integral from 0 to pi is going to disappear. So all I'm going to do is to compute this instead. 3r dz dr d theta. And then over here, I get a z. I can even write it this way. That part, and then 0 to 2 pi, and the inside integral is going to be z going from 5/2 of r to 5, and then dr. D theta is over there, so I have a 2 pi. I kind of took the inner integral out of the outer one. So let's do, here I'll bring the 0 to 2 pi into the very inside. 0 to 2 pi, d theta, dz, dr. I can do that because that's basically a constant. And then the most inner integral is just going to be 2 pi. 5/2 of r to r, dz, dr. Take the integral of inside, and you get, don't forget the 3r, you get 3rz from 5/2 of r to 5, then dr, and then 2 pi. And plugging in z, I get integral from 0 to 2, 3r times 5, which is 15r, and then minus 15, 15, and I have r squared divided by 2 dr. And this is going to end up being 15/2 of r squared minus 5r cubed divided by 2 from 0 to 2. I can simplify the pi, and I get 15 times 4 minus 5 times 8, and from there, basically, what is that? 60 minus 40, that's 20. That's the final answer.